G is in B.
ಮುಂದೇನಂತ ಇದು ಬರುತ್ತೆ ಚೆಕ್ ಮಾಡಿ.
ಗೊತ್ತಾಗ್ತದೆ.
ಗೊತ್ತಾಗುತ್ತೆ.
ಸ್ಟಾರ್ಟ್ ಅಂತ ಬಿಟ್ಟು
ತೊಗೊಂಡಿದೆ
ಇಲ್ಲ, ಇನ್ನೂ 5 ನಿಮಿಷ ಇಲ್ಲ. ಕೆಲವೊಬ್ರು ಬಂದಿದ್ದಾರೆ.
12 ಜನ ಇದ್ದಾರೆ.
ಈಗ ಸ್ಟಾರ್ಟ್ ಅಂತಂದು ಕೊಟ್ಟರೆ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಷ್ಟೇ. ಇದೆ ಅಲ್ಲಿ ಪ್ಲೇನ್
Good afternoon, students. Welcome to the physics class. Now, this is the first class in the B.Sc first year, first semester. So, in your B.Sc, is considered in the physics the different type of the topic. So, one of the important topic is also is there, that is the gravitation. So, already we have to discuss about the gravitation in the primary, high school level and plus 2 section. So I am getting the knowledge. So what is the gravitation? But this small extent syllabus is there in this topic, right? So now first consider. So let us discuss about the gravitation. Gravitation. Gravitation means the force of attraction in between the two bodies. The force of attraction between the two bodies. For example, if you consider any two object or masses of body, so it is the M1. And another one is M2, the mass of body, and another M2. So if you consider two bodies are separated some distance, so some distance. But in between the two bodies, having the force is there. Which force? It is the attraction force. But already you have to study about the electrostatics, positive charge and negative charge. So positive charge and negative charge consider the attractive force, but the positive charge is a repulsive force. Type of it. Means there is the electrostatics, you have to consider attraction and also repulsion forces. But now consider the gravitation, the only consider attractive force. So now, so what is the definition of gravitation? First, the force of attraction between the two bodies in the universe is called gravitation. So now the gravitation is considered mainly the two types. The one is universal gravitation. Universal gravitation. Universal gravitation, and one is planet gravitation. Planet gravitation. So mainly we have to consider the two types of the gravitation. One is universal gravitation, means in this universal gravitation is affected on all the stars, planets, or any another mass of the bodies of the universe. But now consider another one is planet gravitation. For example, if you consider any one body, it's one of the mass of the body. So this mass of the body having the potential energy. Suppose if you release the potential energy, the mass of bodies falls on the earth's surface, because the earth, it contains the force that is called as gravitational force. So this gravitational force is considered as the planet gravitational force. Means the earth is one of the planets and also gravitational force. So this type of, so already you know the different type of the planets. So everyone planets having the different type of the gravitation. So first we discuss only gravitation. Gravitation is universal gravitation and planet gravitation, right? So it is the just only introduction part. Now consider. So the concept of gravitation is discovered by Newton's. The concept of gravitation is discovered by Newton's in 1665. In 1665. We don't know knowledge about the gravitation before the 1665, but Newton's is just observed. Is the some phenomena means the apple is falling from the tree on the earth surface, apple falling from the earth surface. So it is a common or nature, not the natural phenomena. But in this natural phenomena, it is differently thinking. So why the reason apple is falls on the earth surface? That time is taking the another different type of the knowledge about the gravitation. So now the gravitation is discovered by the first Newton's in the 1605. Right? The gravitation is weakest force. Weakest force. The gravitation is weakest force in the fundamental of natural force. So already you know the four types of the natural forces is there, right? So out of four, the gravitation force is also one of the natural force. But in this phenomenon, this force is weakest force, but in the very essential and very role, and the another discoveries or another study about the nature. So it's a very important of the gravitation. So let us come to the next point. So Newton is observed, but he is giving one of the statement on the gravitation. So that statement is considered as universal gravitational law. So now study about the universal gravitational law. Universal gravitational law. Universal gravitational law. So now it is called as the Newton's law. Newton's law. Now it is Newton's law. First, the statement. Statement of Newton's law is thinking about Newton's. If you consider two bodies, it is a mass m1 and mass m2. The mass of body m1 and mass of body m2. For example, you can consider the sun and earth. So m1 and m2. Right? The earth is revolved around the sun due to the force. Which force? Gravitational force. Which gravitation? Universal gravitation and also the earth gravitation. Right? So, but the earth and sun, or we can consider any two objects in the universe, not only earth and sun. So, separated as one distance, this distance is considered as the r. This distance is considered as r. Now, is given the statement about the gravitation by the Newtons, right? Every body in the universe is attracted with every other bodies. Every other body. With attraction of the force is directly proportional to the product of masses and inversely proportional to the square of the distance between them. Is considered only 2 points. Is very important. So one is the force is directly proportional to the product of their masses m1 and m2, and inversely proportional to the square of the distance. Means the distance will be squared, but inverse, right? So these two statements are found a universal gravitational or Newton's law of gravitation. Means, once again I repeat the statement. Every body of the universe is attract with every other bodies with the force of attraction is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Square of the distance between them. Now, F is directly proportional to the m1 m2 divided by r square. m1 m2 divided by r square. F is directly proportional to the m1 m2 divided by r square. Now m1 and m2 is directly proportional, but r square is inversely proportional. Right. Now consider what is the force. Means if a body consider A and B, the force of, so it is called as F12 and F21. So what is the F1 and F2? Very simple. The force acting on the body is due to the mass of body A. So now the force is F12. And also same but in the opposite direction but equal. The force is acting on mass of body A due to the mass of body B. Mass of body B. So it is the force of the attraction between the two bodies. And according to the Newton's law, F is directly proportional to the m1 and m2. F is inversely proportional to 1 divided by r square. If the distance of between the two bodies is increases, the force is decreases. Means r is increases, the force is decreases. The force is decreases. But m is increases and force is also increases. If the mass of the body, you can take the one or anyone, both, right? If the mass is increases, the force is also increases. This is the first step. And next one is, if the distance between the two bodies are decreases, the force of attraction is increases. But if the distance will be increases, the force is decreases. So it is the Newton's universal gravitational law. And next, let us, if mass m1 is equal to 1 and m2 is equal to 1 and r is equal to 1. Next, then F is directly proportional to the 1 into 1 divided by 1. But what is that? What is there? Means 1. So simple, thinking about, before we can take the value of mass, F is equal to Z into m1 m2 divided by r square. m1 m2 divided by r square. So now with the very important step. So it is the directly proportional to the m1 and m2, but inversely proportional to the r square. But F is equal to, suppose the force is equal to, where when the force is equal to mass and separated distance, but we can put in the value of the gravitation. Which gravitation? Constant. So which constant? Gravitational constant. Means Z is gravitational constant. Gravitational constant. G is gravitational constant. Now consider the value of G is 6.67 into 10 raised to minus 11. 6.67 into 10 raised to minus 11. Now 6.67 into 10 raised to minus 11. Now consider F is equal to Z m1 m2 divided by r square. If m1 is equal to 1, m2 is equal to 1, and r is equal to 1. Now consider F is equal to Z into 1 into 1 divided by 1 square. F is equal to Z. Since F is equal to Z, where the mass of two bodies have equal the 1 and R is 1. Now we are getting the value is F is equal to Z. F means the force. The force of attraction is equal to the constant of gravitation. So Z is universal gravitational constant. Right? So this Z value is this the Z value is 6.67 into 10 raised to minus 11. Right? So it's clear statement of the gravitation law. Which is gravitation law? Universal gravitation law are considered Newton's gravitation law. Next. So this gravitation is only applied for universe. For universe, all planets, stars, or any other bodies. But we discuss about discuss about acceleration. Acceleration due to Earth gravitation. Acceleration due to gravity. Acceleration due to gravity. So what is the acceleration? So already know the acceleration is considered acceleration A is equal to velocity divided by t. Means the rate of change of velocity with respect to the time is equal to acceleration. So that acceleration is considered only a body will be motion on surface. But now consider acceleration due to gravity. Acceleration due to gravity. First, so this is the Earth, and in the center of the Earth, consider O. And next, the radius of Earth. Radius of Earth. If consider any one mass of the bodies is placed on the surface of Earth. Surface of Earth. Now it is a small letter m. And now it is one is now consider Earth. O is center of the Earth, and m is the mass of object on the Earth surface or near to the Earth surface. Right? So acceleration due to gravity. Already we know that about universal gravitation. Universal gravitation is F is directly proportional to the m1 m2 divided by r square. This is simple. But acceleration due to gravity is a small changes because acceleration due to gravity is depends on universal gravitation. Universal gravitation. So first we think about the acceleration due to gravity, a mass of body. So for example, this is the mass of the body. The mass of body is placed just on the Earth surface or near to the Earth surface. Near to the Earth surface. So then, now first let the R is radius of Earth and O is center of Earth. M is mass of earth and m is mass of body. First, how to find out the acceleration due to gravity? So it is a just analyze this. This is a data. Okay, is that now consider the first by Newton's law. By the Newton's law. Already we know the statement of Newton's law. F is equal to Z m1 m2 divided by r square. Just you can take the equation number 1. Consider the equation number 1. And now, so it is a normal reaction mg. Means the object is placed on the earth surface, it directed towards the earth surface due to the acceleration due to gravity. So means the force will be applied on the earth surface. F is equal to mg. F is equal to mg, the force of body. So it is called as force of body. Force of body. The force of body. Force of body F is equal to mg is equation number 2. Consider equation 2. Now put in the value of F just in the equation number 1. So equation 1 and 2 we get F is equal to mg is equal to Z m1 m2 divided by r square. Z is equal to but m1 is equal to m and m2 is equal to small letter m. M1 is equal to m and m2 is equal to small letter m. So Z mg is equal to Z m divided by r square. Just replace the value of only m1 is equal to the m means m1. So this is the m1, right? So now m1 we have to consider as the mass of earth and m2 in the m is considered as the mass of m1 m2, mass of object. So now consider mg. Next z is equal to z m. So m we cancel, remaining only r square. G r square. So this is the acceleration due to gravity. Acceleration due to gravity of Earth. Acceleration due to gravity of Earth. Now let us move. If r is equal to r, if r is equal to r, means suppose a body will be is there in this place. For example, body will be this place. So now distance will be considered r. So r, if a body is just on the earth surface, now r is equal to r, the radius of earth and the distance of the two bodies, means earth and body object are the same. So r is equal to r, then z is equal to zm divided by r square. Gm divided by r square. Next, z is equal to G R square divided by R square. G R square divided by R square. So what is the GR? GR means GM is equal to, so already you know, GM is equal to GR square. GR square. So therefore Z is equal to ZR. It's equal to GR. And value is G is equal to 9.8 meter per second. So it is the acceleration due to gravity on Earth's surface. Earth. But this value is variation on the different places on the Earth surface. Remember, not constant value. Okay, so it's the average value. But now consider the constant value of the G is equal to 9.8 meter per second. So it is a G is equal to 9.82 or G is equal to 9.8. The slightly 0.01 to 0.05. The plus or minus 0.1 to 0.05. So 0.001 to 0.005. So this will be changes. Acceleration due to gravity or surface. The different places have different gravitational force. Gravitational force. So this is the concept of acceleration due to gravity. You can consider or you can apply the any planets on the any planets on the universe. For example, so Mars or anyone, right? Okay. So G is equal to 9.8 meter per second. This value only for acceleration due to gravity in the Earth surface, but not others planet. Other planet consider are it having the different values, right? Next, let us come to the next point. You can study about only still Newton's law of gravitation statement and the explanation. Newton's law statement is F is directly proportional to the m square m1 m2 divided by r square, and acceleration due to gravity. Next one is acceleration due to gravity. Acceleration due to gravity is considered G is equal to 9.8 meter per second square. But F is equal to G m1 m2 divided by r square. If m1 is equal to 1, m2 is equal to 1, r square r is equal to 1, then F is equal to Z, right? Now Z is equal to 9.8, so 6.67 into 10 raised to minus 11. So what is the SI unit? SI unit is what? Z m1 m2 is equal to F r square. Z is equal to F r square divided by m1 m2, means m1 m2. So m1 into m square is, suppose if consider m1 is equal to 1, m2 is equal to 1, once the same mass m square. So Z is equal to Newton meter square per kg square. So it is the SI unit of acceleration due to gravity. Sorry, acceleration of universe. Universal gravitational constant. Next, Now consider this is the earth. Very simple. Earth, the mass of body m, acceleration due to gravity, the mass of objects are attracted by the earth. All the mass of object is attracted by the earth, right? Suppose if you just move upward from the earth surface, upward from the earth surface, so now it is considered as acceleration due to gravity, means the force has been affected. But you can move after some distance. Now that gravitational is zero. G is equal to 0. Acceleration due to gravity is 0. Means the acceleration due to gravity is considered in the certain distance surrounding of the earth. For example, the 36,000 kilometer, right? Okay. So this region is considered as the total. This region is considered. This region is considered gravitational field. So it's called as gravitational field. Consider gravitational field. Suppose if any one object is just lifted from the earth surface, the force will be acted. Which force? The gravitational force. Which gravitational force? Earth gravitational force on the body. Suppose if you release the external force, then body is falls on the earth surface. Right? Now, the very important two concepts is arises. When object is placed on the earth surface, the force will be acting. F is equal to mg and F is equal to g upon m2 divided by r square. Right? We are getting the final z is equal to right. Suppose if you lift the body from the earth surface, lift the body from the earth surface. Now we consider the force, acceleration force, right? And potential energy. The potential energy will be increases, right? And again the potential energy will be increases, right? So it will be travel some distance, but after travel some distance or some position, then it will be return. Suppose if a cricket ball will be played, then next it moves this line, and again it reaches earth. The ball is initial stage and is the final stage. Means initial position, final position is earth surface. But where the force will be acting on the object or ball, just it will be rises from the position, some position. But if it reaches the maximum position is the maximum potential energy, but kinetic energy will be decreases. Kinetic energy will be 0. But where the body will be returns to the surface, the kinetic energy is increases, but potential energy is decreases. The final potential energy is 0. Right? Now consider I am telling about the very two important concept. One is if body will be escape from the gravitational force. First one point, and one is if a body will be revolve around the sun. A body will be revolve around the earth. Earth. Now that very important two concepts are we can consider inside the gravitational field or outside the gravitational field. We can consider the satellite, for example, satellite. Already you know, so this is the earth and is the moon. The moon is revolve around the earth. So it is considered as the natural satellite. But man-made satellite will be launched. Man-made satellite will be launched, right? So now it is called as artificial satellite. Artificial satellite, right? One is natural satellite and artificial satellite. We can't control the natural satellite, but we can control the artificial satellite because artificial satellite is man-made. Now, artificial satellite will be launched. Okay, so we getting we want to the initial velocity is maximum. Where the initial velocity is maximum, right? So it will be move the long distance. Otherwise, it cannot move long distance. So it will be returns to the Earth surface because acceleration due to gravity of the Earth. So first, the initial velocity we have to find out how much initial velocity we putting the object. Then object will be escaped from the gravitational forces or gravitational field. So it is called as the one is escape velocity. Escape velocity. And next is how much the velocity, how much velocity is giving the satellite. Then satellite is revolve only in the Earth surface. Satellite is revolve only in the Earth surface. That is called as the orbital velocity. Now, the very important in your examination expression for escape velocity and escape expression for orbital velocity. The two very important concepts. Right. The first is about the escape velocity. Expression for escape velocity. Escape velocity. Expression for escape velocity. Now V E. E means escape. V is velocity. Now expression for escape velocity. Right. The first we consider escape velocity. First, in your examination, define escape velocity. The for 1 marks question. Right. Now we can give the definition. The minimum velocity to escape the satellite or object from the gravitational field. Gravitational field. Or you can consider the minimum speed is required put the object or satellite to the Earth surface. Sorry, to the orbital. For example, now we consider Earth. Okay. So this is the center of Earth, consider O. Right? So it is the object is initially at point, object initially at point A, object initially at point A. Suppose if you give the external energy, then it will be moved. Then it will be moved in the position P. Position P. And again position Q. Then infinity. Then infinity. Right. And the distance between the surface of Earth and the center of the Earth, we can consider capital letter R. So it is the center of means the radius of Earth, and distance between h, distance between x, center of Earth to the position P. And now is the dx. Dx means the small position change should be distance, right? The first one is it is the Earth. Okay, so first consider definition. The minimum speed will be required to put the satellite in the particular orbit. Then it's called as the escape velocity. Okay, so next is the Earth. Consider radius of Earth and point P is initial point P. Okay, and next is the second point Q. Means if a body is initially Earth's surface, then it's applied the external force and give the energy, then it reaches some position P, right? Okay, so just we can take the position P, right? So where the position P, now consider universal gravitation and acceleration due to gravitational P and Earth at the point P and Earth, right? Suppose if it will be move upward the small distance, that is the dx. So dx. Now let us come to the point. First one is R is radius of Earth, and next is just 1 minute. That R is radius and x is distance and dx is small distance, right? P and Q are position, small distance P to Q, and x is distance between P and O. Right. First, according to by Newton's law, means where the mass of object is placed at position P. Now the Newton's law will be applied. So Newton's law, F is equal to Z into m divided by r square. Means now consider x square, because the two in between the two distance consider x. You can take the x or r, right? Okay, but you consider the x. Next, suppose if external energy will be put on the mass of object, then it can move upward from the Earth's surface. Again, it will be travel some distance. Means the work has done. F is equal to, dW is equal to F into dx. F into dx. Okay. Now, therefore, dW is equal to, already we know that the value of F, Z divided by x square. So, Z divided by x square dx is equation number 1. So this equation is represented only the small distance where the travel or where the motion of the object from P to Q. The only work done. Change of work done only. The small work done. Suppose if consider the total work done of the body, a total work done of the objects. If consider total work done, total work done, total work done from where? From distance r to infinity. Distance r to infinity. So distance r means from where limit x tends to x is equal to r to x is equal to infinity. X is equal to infinity. X is equal to infinity. So then integrate above equation. Above equation. Integrate above equation. So means where the integrate, you can consider the total integrate, total the value of the work done. So work done is equal to integration of r to infinity g m divided by x square dx. Right. At the time of the body is just the change of position does not change the mass or earth or object. Okay, earth or object, and gravitation is constant. So now consider g, m are constant values. So we getting the outside from integral, right? Is equal to g m integration of r infinity 1 divided by x square dx, right? And if we integrate 1 divided by x square dx is equal to g m into minus 1 divided by x r infinity, because integration of 1 divided by x square is equal to integration of x square dx is equal to 1 divided by x, which x plus or minus 1 divided by x, right? So applied limit is equal to what then is equal to, so first one is 1 divided by, sorry, what then is equal to minus, you can take the minus outside from bracket g m into the bracket 1 divided by x into r infinity, then is equal to 1 divided by infinity minus g m into 1 divided by infinity minus 1 divided by r, 1 divided by infinity minus 1 divided by r. Next 1 divided by infinity and 1 divided by r. Next, let us come to the next step. Is equal to work done is equal to the 0 minus it will be plus. So work done is g m divided by r. G m divided by r. Now it is a work done where the body will be just motion upward from the earth surface. Right? Now we know that the work done is always is equal to the kinetic energy. Work done is always is equal to kinetic energy. Means work done is equal to the potential energy. Potential energy is equal to the kinetic energy. Right? Okay. Work done is equal to kinetic energy. Now consider. Then kinetic energy is equal to half mve square. Half mve square means v is escape velocity. Now consider escape velocity. Now, kinetic energy. So therefore, of mve square means kinetic energy and work done. Kinetic energy and work done means work done. Kinetic energy is equal to work done. Work done is equal to Z m divided by R. Next, VB. Sorry, the mass, both sides of the mass will be it cancelled. Then next is V square is equal to the 2 Z m divided by R. 2 Z m divided by R. Now, V is equal to square root of 2 Z m divided by R. 2 divided by R. So, it is called as now, this expression will be shows the velocity. Which velocity? Escape velocity. So it is the escape velocity, where the mass of the object is escape from the Earth's surface to the space. It consider or it require the minimum value of the speed. That speed is means velocity v is equal to square root of 2 gm divided by r. 2 gm divided by r, right? Next, v is equal to gm is equal to gr square. Square root of gm is equal to 2 gr square divided by r. Get cancelled, right? So finally, we conclude that v is equal to square root of 2 gr square root of 2 gr. So it's the escape velocity. That means the escape velocity depends on the two properties or two physical quantities. One is gravitational, acceleration due to gravitation, and radius of Earth. And the radius of Earth. Right. So this concept is the expression for escape velocity. Right. And one more concept is the expression for orbital velocity. So expression for orbital velocity. Now we will discuss about the orbital velocity. Right. Okay. Students, so today in this class we will study about the introduction of gravitation. This is gravitation is the attraction between the two bodies. First one is gravitation, and next one is means the definition. In your examination is asking only definition. Okay, and next one is Newton's law. Newton's law. So Newton's law, the statement or an explanation. That two, I think 1 marks or 2 marks just only. 1 or 2 marks. Right. Okay. The Newton's law, F is equal to G m m2 m1 m2 divided by r square. And next is third step, escape velocity. Escape velocity. Escape velocity v e. V is equal to square root of 2 z r. Three concepts are completed in this class. One is gravitation, Newton's law, next is escape velocity. Right? Okay, students, the next class we discuss about the remaining concept, orbital velocity, and other concepts of the gravitation. Right? Thank you.